I am Dr. Binu in Linear Integrated Circuits. The fourth unit is Special ICs. This unit consists of functional blocks and characteristics of 555 timer and its PWM applications. The second topic is VCO IC, Voltage Controlled Oscillator, that is IC566. Third topic is PLL IC, that is Phase Locked Loop, IC565. The last topic is Analog Multiplier IC, AD633. Functional block characteristics of 555 timer and its PWM application. The 555 timer IC is normally used for time-based application. This is introduced by Signata Corporation. It is normally represented by NA555 or SC555. It's available in various packages, normally 8-pin circular type, T099 or 8-pin mini dual inline package and 14-pin dual inline package. 556 timer consists of 555 timers, which is a 14-pin dual inline package. A single 555 timer, a single 555 timer can provide time delay ranging from microseconds to hours, whereas counter timer can have a maximum time range of days. Pin diagram of timer 555 IC. It consists of 8 pins. The first pin is ground, second pin is trigger pin, third pin is output pin, fourth pin is a reset pin, fifth one is a control voltage pin, sixth one is a threshold voltage, seventh pin is a discharge pin, eighth pin is a VCC pin. That is in this pin we have to give the supply voltage. Functional diagram of 555 timer. The functional diagram of timer consists of two comparators. The one is lower comparator and the second one is upper comparator. One control flip-flop, which is a RS flip-flop. That is a reset set flip-flop. The next block is a power amplifier, which will be acting as a inverter, and also it consists of two transistors. One is acting as one is a PNP transistor, another one is a NPN transistor. It consists of three 5 kilo ohm resistors. At the standby state, normally the control flip-flop, the Q bar value is high. At that time the output is low. When the trigger voltage is given to the second pin, the trigger voltage is whenever greater than 1/3 VCC. At that time the lower comparator will be activating. The output of the lower comparator will be high, which is given to the set pin of the control flip-flop. Now the Q output is 1, Q bar output is low. The Q bar pin is connected to power amplifier, so the output of the 555 timer is high. When the threshold voltage is applied, the voltage is greater than 2/3 VCC. At that time the upper comparator will be activated, so the upper comparator will provide high output, which is given to the reset pin. When the reset pin is activated, means Q is equal to 0, Q bar is equal to 1. The Q bar is connected to inverter, so the output is low. Suppose if we want to reset the circuit, means we have to activate the reset pin of the which is that when we provide activate the fourth pin, means the flip-flop becomes 0. The 555 timer can be operated in two modes, that is stable multivibrator and monostable multivibrator. In the stable multivibrator mode, using the 555 timer, the circuit diagram is connected in such a way that that is of the fifth pin, and one pin is connected to by means of 0.01 microfarad, which is used to reduce the noise. Then sixth pin and second pin is connected shorted. Then the sixth pin is connected to ground through the capacitor. The seventh and sixth pin is connected by means of one resistor. Likewise, seventh and the eighth pins are connected by means of another resistor. The eighth and fourth pins are shorted, which is given to connected to the supply voltage. Third pin, from the third pin we are taking the output. The stable multivibrator is acting as a free running oscillator, so here we are not providing any separate input. The input terminal, that is the second pin, is connected to ground. When we are providing the supply voltage, the output is looking like a square waveform, so the circuit is also called a square waveform generator. The amplitude of the square waveform is VCC, that is, it is a square waveform, starts from 0 to VCC. When we are taking the voltage across the capacitor, means the capacitor charging as well as discharging will be shown as in the diagram. The amplitude of the charging and discharging of the capacitor is 1 by 3 VCC to 2 by 3 VCC. That is, the amplitude is nothing but 2 by 3 minus 1 by 3 of VCC. This diagram represents the functional diagram of a stable multivibrator. Time period of the square waveform is 0.69 into Ra plus 2 Rb times C. We can calculate the frequency by means of this time period, which is nothing but 1.45 divided by Ra plus 2 Rb times of C. The second multivibrator using the triple phase circuit is monostable multivibrator. From the name itself, it consists of single stable state. Whenever we are providing the trigger pulse, means at that time it changes its state. So it is also called as one shot multivibrator. The circuit diagram of monostable multivibrator is here. In this diagram, we are providing some separate trigger pulse to the second pin. The fifth pin is connected to first pin by means of a 0.01 capacitor. The purpose of connecting 0.01 microfarad capacitor is in order to reduce the noise. The third pin is the output pin. The seventh and sixth pins are shorted. The sixth pin is connected by means of capacitor. The another end is connected to ground. The sixth and seventh pins are connected by means of one resistor. The eighth and fourth pins are shorted, which is connected to the power supply. The functional diagram of monostable multivibrator is shown in the diagram. The waveforms of the monostable multivibrator is when we are providing the trigger pulse. Negative wave trigger pulse means the output voltage as the pin 2 is looking like this manner. The capacitor charging is represented here. The time period of output voltage as well as the capacitor voltage is same, but the amplitude gets different. The output voltage consists, the amplitude is plus VCC. The capacitor voltage amplitude is 2 by 3 of VCC. Suppose when we are providing the reset pin through the fourth pin, means at once the output changes its state to 0. Okay. Then here the time period formula is T is equal to RC into ln of 1 by 3, which is nothing but T is equal to 1.1 times of RC.